Hi, Michaela. Thanks for sending another question. Again, sorry about the sideways picture here. I noticed you wrote dx dy. I'm assuming you mean dy dx. If you do indeed mean dx dy, this is going to be a very different and much more complicated problem. But if you do mean that, please resend the problem and I'll answer it again for free. So assuming you mean dy dx, let's go ahead and get started. You'll notice I've actually rewritten the function. I've pulled out the constant, which will make things a little less messy when we differentiate. And I've rewritten the root as a fractional exponent, which will make it easier to differentiate as well. So dy dx, we're going to be applying a quotient rule. We'll also be applying a chain rule here. But the quotient rule, in case, just for a refresher, let's say our numerator is function 1 and our denominator is function 2. We're going to take the derivative of the first times the second, then minus the derivative of the second times the first, and we'll place that all over the second as it is squared. So let's go ahead and leave that constant on the outside and get started. The derivative of the first, this is where we're going to be applying our chain rule. So it looks like we have two functions, so we're going to be differentiating this first function up here twice. So let's apply the exponent rule, pull down that 1/2, and we'll rewrite everything on the inside of that as it is, not changing anything. And then we reduce the value of the exponent by 1, so it becomes negative 1/2. Now we're going to differentiate our inside function and multiply that against what we have. This negative doesn't get dropped. It's considered a constant. We're going to pull the 2 down and then reduce the value of the exponent by 1. And this is the derivative of the first. We also have to multiply by the second. So we're going to tack on an x cubed. So that becomes our entire first term. Then we have minus the derivative of the second times the first. Again, I'm going to put some brackets around everything to keep things organized. Derivative of the second, very easy. We'll just apply the exponent rule, drop down the exponent, and reduce the value by 1. And times the first. So we'll just tack on a 1 minus x squared to the 1/2. That becomes our entire second term. And then we'll place that all over the second as it is squared. So x cubed squared. That is very, very messy. So let's go ahead and simplify. Let's go ahead and pull out this denominator first so we can just work with the numerator here. X cubed squared is actually x to the 6. We just multiply those both together, and we're going to pull that out and put it next to the 4, since the 4 is already in the denominator as well, if you couldn't tell. So we have 1 over 4x to the 6. And then on the inside here, let's take a look at our first term and see if we can simplify anything. It looks like I have a 1/2. I also have a negative 2 over here, and this is all a product, so I can go ahead and cancel. Don't forget about that negative x, it's still there. So it looks like we're left with, actually let me go ahead and rewrite this as a root. The square root, that is a negative 1/2. So because it's a negative exponent, it goes in the denominator. So it looks like we have the square root of 1 minus x squared in the denominator because of that negative exponent. And we can certainly multiply negative x times x cubed, and we're left with negative x to the 4th. Let's go ahead and take a look at our second term and see if we can simplify anything. I don't really see anything, but we can certainly rewrite this as a root if we would like. So this just becomes 3x squared times the square root of 1 minus x squared. And then our denominator is already out here in front. Now let's go ahead and see if we can factor anything out. It looks like I have a negative, so I can certainly bring that out front. And I also have, I have an x squared over here and an x to the 4th over here. Those share an x squared. So I can factor out an x squared as well. So I'm going to factor out the negative and the x squared and put those on top and leave the bottom as it is. Since I factored out a negative x squared, I'm left with, excuse me, this is a very good problem you sent, by the way. Okay, so we're left with an x squared in this first term. That, of course, is still over 1 minus x squared. And we factored out the negative, so this is now a plus. We also factored out the x squared, so we're left with a 3 and the square root of 1 minus x squared. It's looking a little prettier. We can simplify the outside here. So we're left with a negative on top. X squared divided by x to the 6th is actually x to the negative 4th, which would be 1 over x to the 4th. We're just going to go ahead and subtract what's on the bottom from what's on top here with the exponents. So we're left with that on the outside. On the inside, we can go ahead and find a common denominator, which is what we usually do if we have fractions with different denominators. So let's go ahead and do that. These are going to share a denominator of the square root of 1 minus x squared. The first term will stay as it is. And the second term will multiply the top and bottom by 1 minus x squared. The 1 minus x squared that's already there will stay there, and then another one will go on top. And also on the bottom. We can now go ahead and simplify further. The outside's just going to stay the same. 1 over 4x to the 4th. The first term is still going to stay the same. The second term, however, is going to change. It looks like in the numerator of the second term, we have a square root of 1 minus x squared times square root of 1 minus x squared, which is the square root of 1 minus x squared squared. Kind of a tongue twister. But whenever you square a square root, they cancel each other out. So we're left with that 3 on the outside. And since the square and the square root cancel each other out, we're left with what's underneath only. And of course, that denominator is still going to be there. Now we can go ahead and combine the terms in the numerator since we have a common denominator. The outside's going to stay the same. Combining the terms in the numerator, we're going to get x squared plus 3 times 1 minus x squared, all over the common denominator that we used. Let's go ahead and distribute this 3. It looks like we have x squared plus 3 minus 3x squared all over that common denominator. And we can go ahead and simplify the top here because it looks like we have some like terms. Let's go ahead and pull this denominator out now. So we have 4x to the 4th times the square root of 1 minus x squared. And we have x squared minus 3x squared, which will be negative 2x squared plus 3. Oh, I dropped my negative up here. Very, very common mistake. There we go. That negative is still there. And we can make this a little prettier by canceling out these negatives and switching the order of the numerator. So it looks like what we're left with is 3 minus 2x squared whoops, my bad. Let's go ahead and correct that. Something didn't seem quite right there. Okay, let's go ahead and fix that. So canceling these out, this is going to become positive, and this is going to become negative. So we will have 2x squared minus 3, and then the denominator will just stay the same. With 4x to the 4th over 1 minus x squared. And that should be your final answer. Thanks again for your question, Michaela, and I look forward to answering more of your questions using Snap Math in the future.